Our next part is third part, which is f of x is equal to e raised to the power x into 1 plus natural log of x. Solution: differentiate a given question with respect to x. F prime of x, which is in left hand side, and on right hand side when we apply derivative, that will become, actually the given function is a product of two functions again, which is e raised to the power x, and the other function is 1 plus log of x. So to differentiate such a function, we have to use our product rule, which is e raised to the power x as it is, and derivative will apply on the second function, which is 1 plus log x, like this, plus 1 plus log x will be as it is, and then derivative will apply on e raised to the power x, which is actually our second function. Now by using our differentiation formula, that will become f prime of x. On right hand side, e raised to the power x will be as it is, and derivative will apply both of these two terms separately. Derivative of 1 will be 0, and derivative of log of x is just 1 over x, which we explained earlier on the start of this exercise. The derivative of log x or natural log of x is just 1 over f of x. Here f of x is x. So to differentiate natural log of x, we have a derivative formula 1 over x plus 1 plus log x will be as it is, and derivative of e raised to the power x will be e raised to the power x as it is. So here again we just explain the formula of d by dx, derivative of e raised to the power. First we write in earlier in this exercise e raised to the power f of x, but here we have e raised to the power x. So just x is actually our f of x. So derivative of e raised to the power x, e raised to the power x, and then derivative will apply on x. As we know that derivative of x will be 1 into e raised to the power x, e raised to the power x. And similarly, derivative of log of x, natural log of x is just 1 over f of x, but we have here x in place of f of x, so that will become 1 over x, and that is similarly derivative will apply on x, which is 1. So 1 into 1 by x will be 1 over x. So we have e raised to the power x will be as it is, derivative of 1 plus log x, derivative of 1 will be 0, derivative of log x will be 1 over x, plus 1 plus log x will be as it is, and derivative of ex, that is actually e raised to the power x. So we have here e raised to the power x. So taking common e raised to the power x as a common factor, we have 1 over x plus 1 plus log of x, which is our required derivative of a given question. Or you can simplify this one by taking an LCM. X will be an LCM, so we have 1 plus x into 1 plus log of x. The next part number 4, f of x is equal to e raised to the power x divided by e raised to the power minus x plus 1. Solution: differentiate with respect to x. Left hand side will become f prime of x. On right hand side, this is actually a function which is consisting of two functions, f of x divided by g of x. So when we apply derivative here, we have to use our quotient theorem. So by using our quotient theorem, we have to take square of the denominator function, which is e raised to the power minus x plus 1 whole square, and this denominator will be as it is, e minus x plus 1, and then derivative will apply on numerator, which is ex, minus ex will be as it is, derivative will apply on denominator function, which is e minus x plus 1. Now simplifying this one, e raised to the power minus x plus 1 as it is, and derivative of ex will be ex. As we discussed in our previous part, derivative of ex is just simply e raised to the power x, minus ex will be as it is, and now to apply derivative, e raised to the power minus x plus 1, derivative of 1 will be 0, and derivative of e raised to the power minus x will become e raised to the power minus x, and then derivative will apply on this minus x, which is minus 1. Ex will multiply by e raised to the power minus x, like this, e minus x into e raised to the power x, plus e raised to the power x multiplied by 1 will become ex, minus and minus will become plus, e raised to the power, as we have a common base e here, so power will be combined, so x minus x will be a power of e. This denominator will be as it is. Again, we have a common base e, power will be combined, minus x plus e raised to the power x plus e raised to the power 0. This x and minus x will be cancelled out. Now we have e raised to the power 0 plus e raised to the power x plus 1. E raised to the power 0 will become 1, and this denominator again will be as it is. So f prime of x will be e raised to the power 0 1, this e raised to the power x, and this 1. So finally the derivative of the given function will become e raised to the power x plus 1, and plus 1 will become plus 2, and this denominator e minus x plus 1 whole square will be as it is. So finally this one is the required derivative of the given question. Now the part number 5, f of x is equal to natural log of e raised to the power x plus e raised to the power minus x. Solution: differentiate given function with respect to x. As here we have just a function containing log, so by using our formula related to log, that is actually 1 over f of x, and then derivative will apply on this function f of x. So f prime of x is equal to 1 over function, which is e raised to the power x plus e raised to the power minus x, and then derivative will apply on this function. Again, we can write it here, or simply already discussed in our start of this exercise, that natural log f of x, that is 1 over f of x, and then derivative of f of x. So that will become 1 over this function, 1 over e raised to the power x plus e raised to the power minus x, and then derivative will apply on this function e raised to the power x plus e raised to the power minus x. So this denominator will be as it is, e raised to the power x plus e raised to the power minus x, and when we apply derivative here, e raised to the power x, derivative of e raised to the power x will be e raised to the power x plus e raised to the power minus x. When we apply derivative on this function, that is e raised to the power minus x, this is actually like e raised to the power x will be as it is, and when we apply derivative on e raised to the power minus x, that is e raised to the power minus x, and when we apply derivative on this minus x, that is minus 1 by using this formula, and in denominator, that is e raised to the power x plus e raised to the power minus x. So f prime of x will be e raised to the power x, this plus and minus will be minus e raised to the power minus x, and divided by this denominator e raised to the power x plus e raised to the power minus x. And by simplifying this one, e raised to the power x will be as it is, and e raised to the power minus x can be written as 1 over e raised to the power x, and in denominator process will be same, e raised to the power x plus 1 over e raised to the power x. By taking LCM in numerator and denominator, e raised to the power x will be an LCM, e raised to the power 2x minus 1 whole divided by taking LCM in the denominator, e raised to the power x, e raised to the power 2x plus 1, this e raised to the power x will be cancelled out. So finally we have e raised to the power 2x minus 1 divided by e raised to the power 2x plus 1, which is our required derivative of the given function. So our next part is e raised to the power ax minus e raised to the power minus ax divided by e raised to the power ax plus e raised to the power minus ax. And you can see that this is actually a function which is consisting of two functions appearing in the quotient form. So just to differentiate this function, we have to use our quotient formula here. Solution: differentiate with respect to x. Left hand side will be f prime of x, and on right hand side we have to apply a quotient theorem. So this denominator will become a square, e raised to the power ax plus e raised to the power minus ax whole square. This denominator will be as it is, e ax plus e raised to the power minus ax, and derivative will apply on numerator function, which is this one, minus numerator will be as it is, e ax minus e raised to the power minus ax, and derivative will apply on denominator function, e raised to the power ax plus e raised to the power minus ax. Now applying formula of differentiation here, this function will be as it is. By applying derivative on both of these two terms, So using a derivative formula of exponential function e raised to the power f of x. So derivative of e raised to the power ax will be actually e raised to the power ax, and then derivative will apply on this exponential function ax, which will become a. Similarly, this minus will be as it is, and derivative of e raised to the power minus ax will be e raised to the power minus ax, and then derivative will apply on this function minus ax, which is actually minus a. Minus this will be as it is, and derivative of e raised to the power ax will become e raised to the power ax into a, as derivative of ax will be a, plus e raised to the power minus ax will be e raised to the power minus ax, and then derivative of minus ax will be minus a. Denominator function will be as it is. This again will be remain same, e raised to the power ax plus e raised to the power minus ax, and from here a will be a common factor, which is this one. So we have e raised to the power ax, and this minus and minus will become plus e raised to the power minus ax, minus again this one is as it is, and from here we have a as a common factor, which is this one. We have left e raised to the power ax, minus and plus will be minus e raised to the power minus ax. Again denominator will be remain same. A will be a common factor from whole of these two terms, from this one and from this part. A will be a common factor, and we have e raised to the power ax plus e raised to the power minus ax, and this is again the same thing, so can be written as in the form of square e raised to the power ax plus e raised to the power minus ax whole square, minus, and this is eax minus e raised to the power minus ax, and this one is again same, so can be written as a whole square form. This a, by opening the square of this function a square plus b square plus 2ab by using this whole square formula, we have e raised to the power 2ax plus e raised to the power minus 2ax, and then 2ab. Here a is e raised to the power ax and b is e raised to the power minus ax, minus by opening the square formula of this one, that is e raised to the power 2x plus e raised to the power minus 2x minus 2 into eax into e raised to the power minus ax. Again denominator will be as it is. So this one is exactly the same result which is in previous slide. A will be as it is, e raised to the power 2x plus e raised to the power minus 2x, and from here 2 as e raised to the power ax and e raised to the power minus ax due to the common base, that is actually e raised to the power ax minus ax. By combining power, that will become e raised to the power 0, which is 1. So 1 into 2 will become 2, and minus will apply on this bracket, that will be minus e raised to the power 2x minus e raised to the power minus 2x, and this minus and minus will be plus again 2 as e raised to the power ax and e raised to the power minus ax will become 1. Denominator will again be same. So from here this plus terms will be cancelled out to these minus terms. We have 2 and 2 will be 4, multiply by a, that will become 4a, and e raised to the power ax plus e raised to the power minus ax whole square will be as it is. So finally this one is the required derivative of the given function.